So we've got a cup factory. They produce beer glasses and champagne glasses. One case of beer glasses makes a $25 profit. One case of champagne glasses makes a $20 profit. Case of beer glasses takes 20 pounds of plastic to make. Case of champagne glasses takes 12 pounds of plastic to make. Every day we can use 1,800 total pounds of plastic. Also, we can make 15 cases per hour of either thing or some combination, and we can work for 8 hours a day. We would like to optimize our profit per day. So we can make our profit function 25 times the number of cases of beer glasses plus 20 times the number of cases of champagne glasses. So let's say let B be the number of cases of beer glasses, and let C be the number of cases of champagne glasses. Then we get this profit function. Let's say let P be profit per day. Okay, and then we have some inequalities. We have 20B, this is for plastic, plus 12C is less than or equal to 1,800. And then we have B plus C. We can make 15 cases per hour, 18 hours per day. That's a total of 120 cases per day. So B plus C is less than or equal to 120. We can also maybe simplify this equation, divide both sides by 4 or something. I like smaller numbers when possible. Okay. And then we'll just try to solve this in any way we know how. This is probably going to end up pretty similar to the farming problem. For the farming problem, method 1 and method 3 combined is actually enough information. So let's just very quickly do that. So method 1 said let's look at these as equalities, and we're just going to solve 5b plus 3c is 450. It's equation 2. Let's take equation 1 times 3. 3b plus 3c is 360. It's equation 3. And if I take equation 2 minus equation 3, I get 2b is 90, b is 45. And then if I look at equation 1 again, then I have 45 plus c is 120, therefore c must be 75. Okay, and then if b equals 45 and c equals 75, then the profit is 25 times 45 plus 20 times 75 is $2,625. And then the big issue with problem 1 from before, which is the same issue now, is that we are not sure that this is in fact maximal. Maybe we can do better. This is one particular answer. Okay. So then along comes method 3. Let's actually go back to our original numbers. So b plus c is less than or equal to 120. Let's make that inequality 1. We won't scale this down. This is the unscaled down other inequality. Less than or equal to 1,800 is inequality 2. Let's take this one and multiply it by 5. So we get 100b plus 60c is less than or equal to now it's 9,000. And then this one is 3 times profit plus 25b. Remember, profit was 25b plus 20c. So 3 times that, we get 60c. We would have gotten 75b. We have another 25b. So that's exactly what we have on this side. That's still less than or equal to 9,000. And then let's take equation 1 and multiply it by 20. So 20b plus 20c is less than or equal to 2400. And then this is just profit minus 5b. So that's almost there, except we have 20 instead of 25. Less than or equal to 2400. Let's call that equation inequality 3, inequality 4. And if I add the two, oh no, sorry, not add the two. Let's, one more thing. Inequality 4, we're going to multiply by 5 now. I want to add the 2 and the b's will cancel. So 5p minus 25b is less than or equal to 1, 2, 0, 0, 0. It's inequality 5. And now I do inequality 3 plus inequality 5. These 25b's will cancel. I get 8p less than or equal to 21,000. So p is in fact less than or equal to 2,625, which is the number we found in method 1. So now we know this is the most it can be, and we have numbers that achieve it. This is the answer. Okay, so the thing that was wrong with method 3 when we presented it by itself is that we weren't able to achieve this bound. We now are. This still seems a little bit ad hoc. So let's look at this graphically. And we'll put the beer axis on the x-axis, and the champagne axis is the y-axis. And now we need to graph these, and then this one was actually, it's a little bit easier to graph. 5b plus 3c is less than or equal to 450 was the scaled down version. Okay, so b plus c less than or equal to 120. Let's make each of these ticks 30. So that'll be 60. That'll be 120. That's my dog growling. Okay, b plus c less than or equal to 120. X-intercept and y-intercept are both 120. We will graph this in black. Okay, we got that line. And then we've got 5b plus 3c less than or equal to 450. So the y-intercept is 450 over 3 is 150. And the x-intercept is 450 over 5 is 90. So that's that line. Okay, and what are we doing? We want both of these to be true. We also want b and c to be greater than or equal to 0. So we're in the first quadrant. And we are under these lines. If you're not sure which side the line is of the line you're on, remember graphing inequalities, sometimes that's a question. Just check a point here. The origin is probably an easy point. 0 plus 0 less than or equal to 120. 5 times 0 plus 3 times 0 less than or equal to 450 is certainly true. Okay, so we're on this side of the origin, or sorry, this side of these lines, the origin side of these lines. And we are in the first quadrant. Okay, so what we found in method 1 was this point of intersection. That's not a great graph because this point is supposed to be 45, 75. Looks like 60, 60. Apologize for that. Okay. But we did graph it right. Okay. That's all right. Not a huge deal. Okay, let's look at this profit function. Remember from calculus, to maximize this, from multivariable calculus, we have a thing called the gradient. The gradient just means what direction on the usually xy plane, but this is the BC plane, do we go that most maximizes P? And we're going to go in this direction. We're going to go 25 in the B and 20 in the C. We can write the gradient as a vector. Let's draw this vector. it's going to pretty much, the x and y are almost the same, right? So but it's a little bit more on the x. So there's that gradient vector. And then remember from calculus, all of your level curves are perpendicular to this. Level curves being values for which are curves on which p is constant. So here are, let me try to draw perpendicular to this. Here are some level curves. And you notice what happens as we go along. We get one of these that's going to hit this point and nothing else that's shaded. Right? The last one will sort of leave the region. The last one will hit this point. That's what shows that this is maximal, because the level curves are getting bigger in value for p, and the last one hits that point. So there's a graphical thing, which is a little bit better than this ad hoc algebra method 3 that I'm not even convinced is going to work every time. But I do know every time I can draw this gradient vector, and I can draw these level curves, and make sure that that point of intersection is the maximum.